All right, so hello again. So anyone who has a question so far? Yes, so yes, man. Yes, so let me just check if everybody is already in front of their computers or smartphones. So just give me thumbs up. 2, 3, 4, 5, 6, 7. Okay, so perfect attendance. However, uh, we're now lacking participants. Before, I think we were 12, so there were two who are not here anymore. Anyway, so let's now proceed to the negative or negative clumper with negative biasing voltage. So since we have the same polarity, so it will be added to our voltage output. Okay, so the only thing that has changed is the polarity of your bias voltage. So it's still the same a negative clumper. It's just that the reference voltage now is a negative bias. So again, I will leave the reading part to you guys, since mostly this one's just discuss the connectivities or the configurations, and what will happen during the positive half cycle, and then what will happen during the negative half cycle. Okay, so here is a summary of a negative negative. So of course we have to start wherein the diode will become a closed circuit. So that is at the positive half cycle. So positive positive and then negative negative. So during the positive half cycle, so we have these two scenarios again. Since negative, our reference voltage is also in a form of a forward bias, since this negative is connected to negative. So you can also, yeah, you can use either, okay, of my ways of how to get the value of VMC of your capacitance. So you can just consider one. So you can just consider one. This is the quickest way wherein VI is greater than VR. Okay, of course, if VI is greater than VR, we only have one flow of current. Okay, and that is this one, just clockwise right here. And this is forward bias by our positive half cycle. Okay, so in here we have plus VI. So for the VMC, we have positive VI, and then after crossing this part right here, this VR right here will also be added to our VR. I mean to our VMC rather. So plus VR. So VMC now is equal to VI plus VR. Okay. Or you can do the other way around, wherein we have two assumptions. We have two scenarios rather, wherein start with VR greater than VI first. So negative to negative, positive to positive. So this will become a forward bias. So during VR is greater than VI. So this will be negatively charged. So we have this flow of current negatively charged by VR, and then positively discharged by the VR also. Okay. So VMC now is equal to negative VR if we are going to consider this current right here, since once VI now is greater than VR, so this will now be charged by the VI itself. So this will be negatively charged by the VI, okay, and then this will be positively discharged by the VI also. Okay, VMC is equal to positive VI. So as you guys can see, we have two different polarities. So VMC is equal to positive VI minus VR. Am I correct? Positive VI. Yeah. And then, oops, feels like there is something wrong. My bad. This is positive half cycle, right? So this one should not be negatively charged and then positively discharged. This one should be positively charged Okay, positively charged by the VI and then negatively discharged by the VI. That is why there is something wrong. So this one is also, where is that one? VMC is negative, that's correct. But VI is good. Okay, this one should be negative. This one is positive VI. Oops, this one is negative. And this one is negative. Oops. Mali pa rin. Mali, mali, mali. Sorry for that. This one should be negative. Negative VI. So with that, we now have here a VMC which is equal to negative VI plus negative VR. Okay. And this one is during the positive half cycle. And then during the negative half cycle, so this will now become a reverse bias. So you can just simply remove this one. Okay, and then all of our currents now will flow to our RL or load persistence. So in here, we can use the formula VO is equal to VI plus VMC. And since this one is negative half cycle, so we have negative VI plus VMC is equals to negative VI plus negative VR. Plus negative VR. Okay. So that's where those formulas came from. Okay. All right, so again, I'll give you guys 10 to 15 seconds to analyze everything and recheck everything. And once you're done, just let me know. Oops. Okay, very good, Mr. Segun. Very good, Mr. Agustin. So this small shift right here is the value of BR, and then this one is still twice of your VI. All right, so very good, Mr. Isagani. Okay, so to those who haven't responded yet, so please let me know if you have a question so we can talk about them now. Okay, so here is the example of a negative negative. So we have 20 volts as our VI and the negative 5 volts as our VR. So let me just this one so we can solve this one. All right, so let me ask someone. So where should we start? Is it positive half cycle or negative half cycle? Miss Magay. Okay, Miss Magay. Right, so I think she's not around. Mr. Santa Cruz.
Sir, positive, sir.
Positive. Okay, very good. So we should start at positive half cycle because again, we need to make this one a closed circuit. So positive to negative in order for us to charge this capacitor, right? So if we have that case, so we can now start with, the two scenarios wherein VR is greater than VI. So at that time, we have this flow of current. Oops. Okay. So negative to negative, positive to positive. So this will become a forward bias. So this will be negatively charged and positively discharged by our VR. Okay. And once the VI is greater than VR, okay, so we will now have this kind of polarity, okay, or flow of current. So this will be positively charged by the Vi, and then it will be negatively discharged by the Vi. So our VMC is equal to negative VR plus negative Vi. I think it's quite quick. So let's just start with Vi first. Negative Vi plus negative VR. Okay. And then for the VO right here, so it's the voltage across this path right here. So we have negative VR. So in here we have 20 volts, and then we have 5 volts right here. So this one is negative 20 plus negative 5, okay, which is now equal to negative 25. And then this negative VR right here is negative 5 volts. Okay. And then during the negative half cycle, so we only have one formula for this one, which is equal to VO is equal to Vi plus VMC. And since we are now in negative half cycle, so our Vi is also negative. So negative Vi, negative Vi, so negative 25. Ah, negative 20 only. My bad, since we have just 20. And then VMC right here is negative 25. So VO is equal to negative 45 volts. And if you guys are going to compare our answer, so we have negative 25 volts for the VMC, negative 5 volts for the voltage output, and then negative 45 for the voltage output during the negative half cycle. So again, I'll give you guys 10 to 15 seconds to analyze everything, and just let me know if you guys were already good with this one. Okay, very good, Mr. Segun. Right, very good, Miss Paklauna. Okay, so if you have a question, again, just let me know. Very good, Mr. Ryan. Okay, very good, Mr. Samuel. Okay, so I guess that's it. So this is actually the last example for the balancing voltage. So let's now proceed to the applications of clampers. So this one is used as direct current restorers, used to remove distortions, used as voltage multipliers, used for the protection of amplifiers, used as test equipment, and then used as baseline stabilizer. So there are many more, but these are just the common applications of a clamper. Okay, so let's now proceed to the charging time and then discharging time of capacitor. So in here, I've mentioned that we will talk about the formula of discharging time and then discharging time, etc., etc. So here is the complete formula of that one. Okay, so for the charging time, we have PC. Okay, well, actually, this is not this one is tau. Okay, tau, and then C is for the well, you can just simply say charging C, and then T is for time. So charging time. So that is one way for you to easily be familiar with this one. So PC is charging time, and then the formula for that one is 5 times RF times C. Okay, so RF is the forward resistance or the bulk resistance. So a while ago, you guys were able to you guys have learned that the reference voltage is equal to the bias voltage. In here, we have another terminology which is the forward resistance. So this one is just the same with the bulk resistance. So those two are just the same. Okay, so don't get confused with those two. Okay, so 5 times RF or RB times C, which is the capacitance. Okay. So this is the thing that you guys need to memorize when it comes to charging time. So if you have charging time, we also have discharging time wherein it's called PD. Okay, so D for discharging and then T for time. Okay, so PD. So it's equal to 5 times RL times C. So RL right here is the load resistor and then C is for the capacitance. Okay. So yeah, just be familiar with those formulas since yeah, we are open notes, so there is no you're not required to memorize this one since everything is open notes anyway. All right, so let's have this example. So calculate the charging and discharging time of the circuit and find the V out during the positive and negative cycle. So consider the forward resistance, which is equal to 0, and the V peak of positive 15 volts during the positive half cycle and the negative 5 volts during the negative half cycle. So in here, there is also something new with our voltage input. So it's not always the case that if we have a VI of, let's say, 15 volts, it's now peak to peak positive and negative. So we can also have this one, let's say, positive 15 volts during the positive half cycle, but we can also have here a negative 5 volts only during the negative half cycle. Okay, so that is also a possible thing in a voltage input. Okay. All right, so in here, we have here the, of course, the voltage input, the capacitance, and then the diode, and then the reference voltage or the bias voltage itself. Okay, so in here, all right, so in here, where should we start? Is it positive half cycle or negative half cycle?
Positive, sir.
Okay, very good, Mr. Agustin. So of course, we will start with positive half cycle because we want to charge our capacitance first. So what is our value? We have plus 15. So we have plus 15 and then negative 5 volts. Okay, so since we are in a positive half cycle, so we will use this value right here. So in here we have plus 15. So this will be positively charged by our VI, or we can just simply use the one shot computation, which is VI is greater than VR, since this reference voltage right here is in a reverse bias connection with our ideal diode, so we cannot have an assumption that this will be positively charged and then negatively discharged by this reference voltage. So we'll just use this VI is greater than VR. So we have here plus 15. Okay, and then we have here negative 5, because the one that we're going to consider is this symbol or this sign right here, plus negative 5 volts. Okay, so we could say that we have a final value of positive 10 volts. Okay, in here for the voltage input. So with that, this will be positively charged by the VI, and then it will be negatively discharged by the VI also. So from positive 10, it will become negative 10 volts. Okay. And of course, so this is the value of VMC, right? Negative 10 volts. And then for the value of VO, we have here positive 5 volts. Okay, since the one that we're going to consider is this one right here. And then during the negative up cycle, so we only have one formula, which is VO is equal to minus VI plus VMC. So minus VI is minus 5 volts plus VMC is negative 10 volts. So VO is equal to negative 15 volts. So let's compare if we have the same result. Okay, so yes, we have the same result. So -10, +5, and then -15 volts. And for the charging time and discharging time, so you'll be having a problem with this one since if everything is already given, then all you need to do is compute that one. Okay, compute for that PC and then TV. So 5 times RF is 0 since it's indicated right here that RF is equal to 0. So any number that is multiplied to 0 is equal to 0, of course. And then the discharging time is 5 times RL. So RL is 10K. And then times C is equal to 1 micro. Okay, microfarad. So as a result, we have here 50 millisecond or 0.005 second.
So kahit
So
ano ba pares acceptable pa din, either seconds or milliseconds.
sa ano,
Sa charging and discharging time. Or dapat seconds sa charging and sa discharging milliseconds talaga.
seconds, yung the unit for the charging time is as seconds. So I've just used here millisecond because this will be 50 in terms of millisecond. But if you want to equate this one into seconds, so just move 3 zeros. So this will become equal to 0.05 second. So either of those two, they are just the same. So was I able to answer your question? I can actually.
Yes, yes sir.
Okay, kasi I cannot hear your voice clearly. Okay. Feels like it's echoing. Anyway, so as you guys can see right here, it's like, the time that there is a current, okay, on the capacitance, it will instantly charge since the charging time is 0 seconds. Well, in reality, so maybe there is still a small delay, like 0.0000005 or 0.01 seconds. So it's not like constant, but maybe because it's super small, so we can just neglect that one and we can just say that it's instant or 0 seconds, especially if we don't have a forward resistance of this diode right here. But in reality, all of the diodes has a forward resistance. There is still a small uh, resistance or a bulk resistance for a diode. Okay, so this could be 0 point something. Anyway, so once you guys are already good with this one, so just give me a thumbs up. So just to let me know that you guys were able to get everything. So the only additional one right here is this charging time and discharging time plus the different value of our positive half cycle and then the negative half cycle. All right, so that's actually it for this clampers. So this is the reference of this PowerPoint, and I just have an announcement. So may I know those people who plays Mobile Legends? Please give me thumbs up or uh, any reaction just to let me know that you are playing in Mobile Legends. So I highly encourage everyone. So this one is exclusive for computer engineers only. So I don't know if you guys have already saw the announcement. So there will be a regional tournament. So saan ba nila pinost yan? Yatin. Okay, so if you're not in this group yet, so please join now this UC Computer Engineering. So there are 267 members. So some of you are already here, maybe. So there will be a regional, okay, regional virtual challenge. Okay, this is exclusive for CPE students only. So this will happen on October 16, October 23, and then November 11. So depending on the event. So the Mobile Legend Mobile Legend tournament will happen on October 16, 2021. So of course it's a 5v5 tournament. So having a main 5 players is required, and then plus one reserve, or ito yung parang 6 month. Okay, it's like the optional one just in case one player became sick at that certain date of tournament. So that is why we have here, we have here one reserve group. Okay, so we also have others like Quizbowl and then pitching and then programming, but I'm not the one who's in charge with those events anymore. Okay, so if you guys are interested, so please message me or PM me. But before you guys will message me, I want you guys to form your team. So please call the others. So it doesn't matter if what year level you are, as long as you're a CPE undergraduate, as long as you're still a student in UC, okay, and then you're a computer engineering, okay, so we can have a first year or second year, third year, or fourth year, okay. And I would like you guys to form a 5 players. Okay, so here's the membership fee per student. So this one now is, I know that this one is quite expensive, but don't you guys worry. There is a reason for this one, since this will be like your like parang membership, like a membership fee for the ICPEP organization. Okay, so once you've joined this tournament, you will become a ICPEP member at the same time. Okay, so I think it's for 1 year. Okay, so that is why we have this membership fee per student of 250 pesos, and then registration fee of 500 pesos per group. Okay, so this registration fee per group is separate with your membership fee per student. So if we have 5 members, so 1,000 plus 500 is equal to 1,500. So yun na nga, it's a little bit expensive. Okay, but don't you guys worry. This is one of a once in a blue moon event that you can join in your entire life. So while you're still a CPE student, so why not? So you'll be able to compete with these universities or these institutions. So we have Lagawe campus, the Pocha campus, and then we have the Kalinga State University, and then of course our school, which is the UC, and then we have here, what is this, University of Baguio, yeah, UB. Okay, so there are 5 universities who will compete for those events. Okay, so yeah, yun lang naman. So I hope you guys will be interested and then represent, okay, our university. So of course, you're not going to pay yet, okay, unless you are already a final member of the team. Okay, so there will be a like a tryout. So I will just check. Okay, so titignan ko lang kung ano yung na-form ng team. Okay, so I'll just check if uh like the team is already good enough, since there might be 10 players who are interested, or let's say 15 players who are interested. So we have to reduce that into 6 players only. So 5 main players and then 1 reserve player. Okay, so there is a cash prize for this one, of course, for whoever was going to win, I guess. So I'm not just sure how much, and then there will be a certificate, I guess, if I'm not mistaken, and then there will be a medal at the same time. Okay, if I'm not mistaken. So those are not yet final, but yes, of course, you'll be having an award or a reward for the champion. Okay, so I'll be posting a separate poster later on, okay, for the UC invitation for the Mobile Legend only. So please, as early as of now, please form your team. Please message your classmates, your seniors, or maybe your freshmen,
if you know some freshmen who is good with Mobile Legends, so please let them know. Please let them uh, join our event, our CPE event. Okay. Mr. Segun, do you play? Do you play Mobile Legends?
No, sir.
Okay. All right. So if you're not playing Mobile Legends, so maybe you can join the quiz bowl, maybe, or the pitching or the programming. So I don't know who's in charge. I forgot who's in charge with quiz bowl or pitching. So you can either ask Sir Tandingan or Ma'am Teresa. Okay, Ma'am Tere. Okay.
Okay.
So they are the one who's in charge with the other event, who's going to represent the UC institution. All right. So those are the dates when will those happen. Okay, so any questions so far or clarification regarding with event? So one more thing is you really have to have a good internet connection, because it's not just that you are going to play with your phone, but you have to you have to, like, it's like a live, okay, live competition wherein you are going to use a Zoom meeting just to show that you it is really you that playing on that Mobile Legend character. Okay, because if it's like, if there is no camera, so there is a chance that yes, you're the one who's registered, but you will let someone who's really good in Mobile Legends to play instead of you. So it should be live, okay, with the use of a camera. So if you guys have saw a tournament, uh, nowadays, since Mobile Legend is wala ba akong mga recent watch dito. So this Mobile Legends tournament 2021 is now live. Maybe at the end. Saan ba? Dito eh. Like after the game, they have to show that they are really the one who is playing. Anyone who saw something like that, Mr. Samuel? I hope nanonood kayo ng mga tournament ng ganito kahit papaano.
Sir, yung sa MPL ata, sir. Tapos
Ano
may
yan?
camera yung sa MPL, sir.
MCL.
MPL, sir. MP.
Yeah, something like that.
Ayan.
This one.
Yan, sir.
So
Yan, sir.
supposedly it would be something like this. Okay, like this would be a live wherein we can see that it is really used playing at that game. But since we are separated to our homes with each other, so you just have to open your camera and then just before the game will start, just show in front of your camera your phone that you're the one who's going to play. Okay, and then while playing, so we can see your face, something like that. So parang ganun sa akin gusto kong ibig sabihin. All right, so yeah, that is another additional requirement. So it's not just that you have your phone. It's not enough, unfortunately. Just to avoid cheating, of course. Okay, kasi mamaya baka yung naglaro, it's like 2,000 stars or 3,000 stars, and then the players are only like say a mythical glory 600 or 500, but that player who's playing is a pro, yeah, 2,000 or 3,000 stars. Okay, so just avoid those cases. So yeah, Mr. Samuel, please call your other classmates, like maybe I think Mr. Ano ba yung naglalaro? Si Mr. De La Cruz, right? And Mr. Cerces Bautista, I think they are also playing. But of course, we have to, screen everybody. Okay, I think it's quite easy when it comes to screening. So rank na lang natin. Let's just rank from top to bottom. So if we have 1,000 stars, and then the second one is 800, 500, 400. Okay, so ganun. Okay, or depende kung ang rank nila is mythical lang, and then yeah. So let's just rank that one with the say M1, M2, M3, M4, then M5. So are we clear with that one? I think everybody is playing except Mr. Segun. This Paclao, now do you play? Mr. Ryan, Mr. Mabanta, Mr. Agustin.
Yes, sir.
See, even Miss Paclao
I
is
used
playing.
to.
Since his brother is a gamer. Okay, so ilalang
No,
kilala
sir,
kayo.
I do not play ML.
You do not play, so you're the complete opposite of your brother. So uh, he doesn't have enough
Well, not
achievements.
ML. I play games, sir, but not ML specifically.
Not ML. Okay. I think your brother is not also playing ML. So he is like more into MMO RPG. Maybe Genshin
Yes, sir,
Impact
RPG games.
RPG. So we pass. Yeah, it's two complete game. So anyway, so we don't have enough time anymore. So yeah, just let your other classmates know, and then we'll have a screening before October 5. Okay, so the earlier the better. So the official date of Mobile Legend tournament is October 16, but we'll be forming a team before October 5. Okay, so you could just say that I am your coach in Mobile Legends, though I am not that good in playing in Mobile Legends, but I am the one who's assigned to monitor or who's going to form a team in Mobile Legends. Okay, for the UC institution. Anyway, so just wait for the another tarpaulin or announcement. Okay, so again, please join this page right here. Okay, UC Computer Engineering. So goodbye and thank you guys for coming. If you have questions, so just let me know. Feel free to message me anytime. Okay.